Okay, now we will go through the next one, which is what we call as subroutines. So in PLC, we have the instruction subroutines to designate programs that typically in a traditional language or lower level language programming, such as C program, or even object-oriented programming such as C++ or a Java program, you have what we call functions, which is usually with functions, we write separate functions from the main program so that the main program is not really long and it's just going to be, usually with a main program, you just wanted to kind of put the instructions that are not repeated and as simple as possible, so it's easier to be checked and to be debugged in a program. So that's how you usually plan for a main program. So the same thing happens in PLC. So the subroutines are basically introduced into the program, into the main program, so that for the functions that are that can be used repeatedly or seldom used. For example, some processes will probably just require that out of, for example, after 100 cycles or after 200 cycles. So you don't really need that in the main program, but you wanted to have that functions available, so you can write that in subroutines. Okay, so the subroutines in PLC is equal to the functions that you have in a low-level language programming language. So subroutines basically break larger control tasks into smaller ones and enable you to reuse a given set of instructions. So in PLC, you have 3 different instructions that you use together for executions of subroutines, which is subroutine enter. It is defined by SBS, and subroutine define SBN, and return RET. So when the main program calls a subroutine, the control is transferred to the subroutine and the subroutine executions are executed. So a subroutine can be executed by placing the SBS with the subroutine number in the main program at the point where the subroutine is desired. And you can see here that the ladder symbol SBS must be immediately followed by the data areas, the subroutine number. Okay, so you have from 000 to 255, which means you can have 256 subroutines in maximum in a program. You will have the same SBN or subroutine define number, okay, to define where your subroutine is, and the return, which is between subroutine define and return is basically the gate, or the fence that says where your subroutine should start and finish. Okay, so when SBS is executed, okay, when you activate the contact to the SBS instructions, the instruction between SBN with the same number and return, okay, the first return will be executed. Okay, and then when it is finished, it will go back to the line after the subroutine rung. Okay, so that is how the subroutine is made. Now the subroutine also can be nested. Okay, so you can see that here, for example, you have 3 different subroutine, right? So you have subroutine 010, and then you have subroutine 011, and you have subroutine 012. So nested means like you will have subroutine inside the subroutine inside the subroutine. Okay, so when, for example, subroutine 010 is called, Okay, so when you call 010, or you activate the execution to 010, then it will straight away go to that subroutine. Okay, so when it goes to that subroutine, inside that subroutine, it has also the call to another subroutine. So when it goes to this subroutine, it will straight away go to where the subroutine is, return, right? So it will go to SBN 011. Okay, so then it will execute whatever instructions inside that subroutine 011. So say that inside subroutine 011, you also have another subroutine which is 012. So when it is called, it will go straight away to where subroutine 012 is, execute whatever inside there until it met the return. Okay, so when it met the return, then it will go back to the line after the line of calling the subroutine 012. Okay, so it will go to that line and execute the rest of the subroutine. And then when it finish, or it first see the return line, it will go straight to the line after the subroutine 011 that is called before that. And also it will go straight to whatever lines left after that subroutine 011 call. And then when it reaches return, it will go to the line next to the line SBS 010. So basically, this is how you can nest basically in here 3 different subroutine inside one single subroutine. Okay, so you can see here that inside subroutine 010, you have subroutine 011. Inside subroutine 011, you have subroutine 012. Inside subroutine 012, you have nothing. So you will basically return back into 011 and then 010. Okay. Now, let's see one example of how subroutine is applied, okay, in the end automation process. Say, for example, that you want this pilot light to be continuously flashes whenever there is some material on the conveyor. So as it is disseminated from the tank, so you will have the light flashes as the material is conveyed throughout the conveyor. So now, if the weight on the conveyor exceeds the preset value, the solenoid is de-energized, and de-energized means like basically the tank will turn off and the alarm light will begin flashing. And when the weight sensor switch closes, okay, the SBS is activated and processors can jump to the subroutine area. The subroutine is continually scanned and the light flashes. And we can see slightly here that the subroutine is basically used to flash the lights. And then when the sensor switch opens, the processor will no longer scan the subroutine area and will return to the on state. So basically, if there is no material on the conveyor, then we will not have the light flashes. Okay, so the function of the subroutine is basically to just flash the light to ensure that the material is on the conveyor. So I've written the program here, and you can see that the subroutine is defined. So we only have one subroutine here, and I use a subroutine number 1. So I have a subroutine here, so subroutine enter here, and then I have subroutine define here. And in my subroutine, basically I have 2 timers. Okay, so the timer to turn on and the timer to turn off. And I have the pilot light here is turning on by the timer. Okay, and also the weight sensor. Right, so basically if the pilot light will flash if the execution condition here is off, and will turn on when the execution condition here is on. So you can see here that the pilot light will turn on regardless of the subroutine as long as the weight sensor is off, or the weight sensor here is represented by a normally close contact. So so the sensor, if it is if it doesn't exceed a preset value, then it will stay on. All right, it will not stay on, sorry, it will stay in a normally close contact. All right, so the pilot light will not flash. So so when it is exceeding a preset value, then the pilot light will start to flash lah. Okay, so here you can see that I also take care of the solenoid as well as the motor. Okay, so the motor will start with the start button, and the solenoid will be off by a weight sensor. So when it is exceeding some preset value, we will, so see, when it is exceeding a preset value, the pilot light will turn off, and this line will turn on, and it will go straight to a subroutine. Okay, so when obviously if you go straight to the subroutine, then this timer will start counting. Okay, so when this timer start counting, so execution of T001 will be delayed by here set value is 10, so 1 second, so it will turn off for 1 second, and it will turn on for 1 second. Okay, so when timer 002 is finished, then it will break this line and therefore reset the timer. Okay, so we will see that in a CX program after this.